So to start off, let's show that the code works. You can type either in the letter or the word that is specified in these sections. If you put in something like Y, it will just bounce you back. So you pick a valid method, which is one of these. It also does process 1 and 2 for the A star 1 and A star 2. This is the path that it takes. Here's all the specifications for the table. And moving on to the code itself, it all basically happens in this node, or with this node. This is an existing Python library, so I decided to just use that. This basically just sets up the start node. Then for getting all of the children, it does the same command except up, down, left, right. And each of those looks for the 0 position where it's at. Then if it's there, it swaps the position, then returns the node for what the child would be. Otherwise, it returns none, which will be used in a few other, well, it will be used in the functions later. This is for comparing heuristics, used in many functions. Swap, basic swap, toString, creates a string of the state and makes it for comparison reasons. That will be used in the other stuff. Set heuristics, does what it says. This finds the path that it took to get to the end. This one prints it. Number of misplaced, does as the name implies. Manhattan distance, this calculates Manhattan find value, used here. Then now breadth first search. Now all the code is pretty much the same except for a few details. For one, the queue is different depending on the algorithm, and a lot of the stuff revolves around what's in this for child and current child function. All of the nodes are put into the queue, and then put is just native for queue. Visited is a set, and to start off we put the starting node in there, and nodes.get is just the remove and return item for the queue library. And to prevent duplicates, visited is there, and it compares two strings to make sure that it's never visited again, and none, it was, if a move returns none, we don't want to do anything with it, so it just gets sent. It just never gets used. BFS and DFS are same except for LIFO queue versus queue. UFC uses priority queue and uses heuristic of the total cost of the child. Greedy best first, priority queue, and this one just uses heuristic of number of misplaced tiles between the child and the goal. A1 uses the same thing except it as in the child cost to the number of misplaced. A2 is similar to A1 where it uses child cost but instead uses Manhattan distance between. All of them use the same put and get methods because of how the native library works. this is just the stuff for printing out the stuff for the user to enter into.